Okay, so in this video, we're going to be finding all of the real zeros of f of x equals 10x to the fourth minus 15x to the third minus 16x squared plus 12x. So what you might notice here is that each of the terms has an x in common. So we're going to go ahead and we're going to factor that out. So we're actually going to have f of x equals, we're going to factor out our x, and then that's going to give us the 10x to the third minus 15x squared minus 16x plus 12. And now from here, we need to find a list of rational zeros. So we need our factors, so 1 and 10 and 2 and 5. And for 12, we have 1 and 12 and 2 and 6 and 3 and 4. So for our list of rational zeros, we're going to have kind of a big list. So one way to write this is to also, let's see, let's make it real quick. Sort of be vigilant as we're writing these to make sure that we don't overwrite things or write them too many times. So we'll start with our 1. So we have 1 over 1. Then we're going to have a, so there's, the 1's going to go with 4 things. The 1's going to go with the 1, the 10, the 2, and the 5, right? So each time it's going to go with 4 things because there are 4 red factors. And so we know we're going to have like a 1, a 10, a 2, and a 5. So the next green is a 12. So this is kind of like a quick way of making these lists so that way you can not spend forever doing it because it's kind of long and tedious to do. So let's see here. So we have the 1, the 10, the 2, and the 5, the 1, the 10, the 2, and the 5. And we're on the number 2. And then we're on the number 6. See, we still have 2 more of these to do. So plus or minus. Oops, got an extra comma in there we don't need. And then lastly, let's just move this up a little bit so we have a little more room. So we're not squishing anything in there. So plus or minus. All right, so again, 1, 10, 2, 5, 1, 10, 2, 5. So we'll do the 3's. And then the last factor, which is 4. And then these reduce, right? There's kind of a lot happening here. So our real list, we'll break it down, make it a little bit smaller. So we have 1 over 1, which is 1, so plus or minus 1. And then 1 over 10 is the only 1 over 10. Let's see, 1/2. So let's go through. Are there any others? So we're going to mark off the things we already have. Like we have a 1, so we're going to cross off anything else that equals a 1. So that equals a 1, we don't need that. And that's it. Okay, so we have a 1/10. Any other 1/10ths? Nope, I don't see a 1/10. So now the 1/2s, we have the 1/2 written. So 1/2s, nope, 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 nope. That's 1/5, that's 2/5, 6, no, 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 no. Nope, no more 1/2, so the 1/2's by itself. Then we've got our 1 over 5. And so we have another 1 over 5 I thought I saw. Let's see, let's double check. No, no, no. Oh, there it is, 1 over 5. So I'm just looking for the things that reduce to that to make sure I get my full list. So if you were asked to make a list, this is what you would need to do. Let's see, we have a 12, so that's a whole number, so we'll just move that away, and that's the only 12. And now 12 over 10 reduces, okay? 12 over 10 reduces to a 6 over 5. So we can go around and see if there's any more 6 over 5s. Oh, there's one right there. And I believe that's the only one. Okay, so now for our next one. So plus or minus, and we have 12 over 2 is a 6. So we can cross off that 6. And there's a 6 right there. And I think that's it. All right, so then our next one, plus or minus, and we have a 12 over 5, and that doesn't reduce, and that's the only one of those. And then we have a plus or minus 2 next, so plus or minus 2. And we've got some more of those, so that's a 2. And 6, let's see, where was it? 4 divided by 2 is a 2. All right, so now 6 over 10 reduces to a 3/5. To a 3/5. Oh, it looks like I skipped one too, but let's do this first. So 3/5, cross that out. All right, I forgot the 2/5 right there, so I need to make sure I write that one down. So plus or minus 2 over 5. And let's see, 6 over 2 is a 3. We don't have a 3 yet, so a 3. There's 3 over 1 right there. Do we have a 3 over 10? Nope, so we can write that one down. Plus or minus 3 over 10. And then we've got 3/2. We don't have a 3/2 yet, so plus or minus 3/2. Cross that one out. We don't have a 4 yet, so plus or minus 4. And then a 4/10 reduces to a 2/5. We have a 2/5, so we can cross that out. And then we have the negative 4, or the plus or minus 4/5, which we don't have yet. So these right here, that huge old list, are all the possibilities. Now that's going to be pretty rough to try and plug that all in, right, using synthetic division. That's a lot of choices. So we're going to use our calculator to kind of help this along. So I'm going to give us some more space. So we're going to grab our graphing calculator and we're going to plug in our equation right here, our 10x to the third minus 15x squared minus 16x plus 12. So we're going to plug that in and we're going to hit graph. And we could probably zoom in a little bit to make this a little bit easier to see. So I'm just going to zoom it in to make it a little easier. Okay, so I've got my 3 spots. So I'm going to use the trace feature. And what I'm going to do is I am just going to trace till I can get right up close next to it. I want to know when is y 0. And so here I've got 0.658. So that's about a negative 1.06. So negative 1 might be a good choice. So we can write that down. So a good option for us to try is x equals a positive, or excuse me, that was in the negatives, so a negative 1. And let's see what else would be a good choice. So let's go look at this other side over here. And we're going to see that as we get lower, that a negative, so let's see, so we've got 0.56, right? Because y is about 0 and we're at 0.56. So an x is about 0.56. And then lastly, if we just move a little bit farther over, we look like we're going to be at, oops, so we get kind of close. So we're at 0.03 and a 2. So something less than 2, right? Something smaller than 2. So that's a little bit harder. We probably don't have one that we want to plug in there. Let's, because we're super close. So I wonder, let's try a 2. Let's try a 2, because we're a little bit above and a little bit above here. So let's make 2 our other choice. So maybe something like 2. So now we have a much smaller pool to try and choose from. We probably don't want to try the 0.56 because that's going to be a hard number. And so we're going to go ahead and we're going to try our synthetic division. So we're going to use 10, negative 15, negative 16, and the positive 12. And let's go ahead and let's try that 2. Let's try the 2. And so as we do that, bring down our 10, and then we're going to multiply. That's going to give us a 20, and then that's going to give us a 5, and then we're going to go ahead and we're going to multiply, and that's going to give us a 10, and we're going to add, and that's going to give us a negative 6, and then we're going to multiply, and that's going to give us a negative 12, and that's going to give us a 0. All right, so the 2 worked. Great. Okay, so the 2 looked good, right? X equals 2 is a choice, so we'll put it up here. X equals 2. Love it. Okay, now, so something that we can do to make this pretty easier, a lot easier. Remember this represented the x to the third, x squared. This was the x, and that was the constant, right? So this is going to break this down. It brings it down a degree. So x squared, the x, the constant, and this is the remainder, which there wasn't one, right? So that doesn't really matter. We can rewrite this. So remember, originally, remember up here, we took out that x. So we can write this again as an x. And then our 2 right here, that's going to be an x minus 2. And then we have this leftover piece. We have that 10x squared plus 5x minus 6. So from here, what we want to do is we want to see, can we factor that piece right there? And we might not be able to. What might be easier is to plug this into the quadratic formula. Right? So in that, we're going to do it with just the orange piece, right? Just with this portion right there. And so doing that gives us an a value of 10, a b value of 5, and a c value of negative 6. So when we plug that in to our quadratic formula, we put our b and b squared, and then a, c, and a, right? So now we can take that, we can just plug that in to our calculator, like just like we see it, right? So let's say we bring up our calculator. So we bring up our calculator, we go ahead and we open up our piece, and we get a fraction. So we've got negative 5, we'll use the plus this time, square root of 5 squared minus 4 times 10 times negative 6 all over 2 times 10. And we're going to go ahead and we're going to hit enter. We're going to get 0.56. Now that was one of the things that we had seen as one of our possible answers. And so we can write that down, and we see that this is not rational. This is going to be an irrational 0, which is fine. So now we're going to plug in all of our stuff again. So I'm going to do second enter. Oops. Let's try that again. So I'm going to hit second enter. And this time I'm going to go ahead and I'm going to go back up. Oops. And arrow over to my plus sign over here. Oops. And change it to a minus sign. Then hit enter. And I'm going to get a negative 1.06. So our negative 1 that we saw was close, but it's actually negative 1.06. So x is also approximately negative 1.06. And so now I've got all 4 of my answers, because remember, we're looking for 4 solutions. So in this case, we can see that we have our, let's use a color. We have our x equals 2, right, that we found using our synthetic division. So we have x equals 2. We have, when we take this and we set that equal to 0, we get our second 0. And then we're going to have our x is approximately 0.56, and x is approximately negative 1.06. And so x equals 2 and x equals 0 are our rational solutions, and x equals 0.56 and x equals negative 1.06 are our irrational solutions. And so the longest part of this was really making the list of our zeros, of our rational zeros, and then rewriting them so that we'd know what to pick. And so there's ways to streamline doing this to make it a little bit faster and easier. And a lot of it is just practicing really and seeing the overlap like right away and not rewriting them. So that is how you solve for all of the real zeros when there are rational and irrational zeros. And again, these were our solutions.